Have you seen this? Some of the people at Rivian have shared their insights on the development process of their new HMI design at a talk during the Unreal Fest in Seattle last year. I have analyzed it and thought I would share some of the key learnings with you. When someone breaks from the mold, I always find it interesting to learn how and why. So let's talk about Rivian's design choices and some of the techniques I've used to realize this. Strap in, let's learn from the pros. I know, I've already made a video about recreating the 3D art style of Rivian's car visualization. You can take a look at it here. In this video I'd like to break down some of the techniques that have been used to create the actual visualization and give you my take on it, as well as recreating a few things here and there to demonstrate. Maybe we also do a quick comparison between my first iteration and this one at the end. I'm not going to dissect the whole tech talk, but rather focus on the points I found most interesting. Feel free to watch the video of the talk yourself. I've linked it in the video description. It's a great talk that's packed with useful information. Rivian has changed their design from a photorealistic visualization, which most major car manufacturers use, to a much more unique and stylized approach. Here's a side-by-side of the older design and the current one. They wanted the UX in their cars to feel like the brand, bold, playful and ambitious. Their early design inspiration was drawn from anime and stylized media and followed mostly the Studio Ghibli aesthetic. Like many other electric cars, the Rivian can change the way the motor, suspension, etc. work based on so-called drive modes. So you have an all-purpose drive mode, which is meant for most scenarios, but you also have a mode for snow, sand, terrain, stone, and so on. In each of those modes, many parameters are adjusted, and on the center screen they are visualized in 3D with the car in a corresponding environment. The scenes change based on the drive mode selection, with a nice animation of the car's wheels turning as if it was driving into the new environment. The team has focused on the camp mode during the development to finalize all aspects of the design and create a cohesive and polished overall look. To have full control, they chose to use color and line weight to communicate depth and focus instead of relying on the traditional use of directional light and height fog. This is the look of the camp mode in the final design. The design has developed into a stylized anime style mixed with technical line art. Now, how did they achieve that look? What techniques did they use and why? First, let's look at what they wanted to achieve. They wanted a fully interactive 3D visualization, full control of the visuals, minimize on performance cost, and minimize on storage space. All of these aspects were important when making the choices they made. I'm going to approach this from an Unreal Engine developer's perspective, since this is what Rivian also used. But you should be able to achieve similar visual results with other engines as well. I'm also going to focus on the car and not the environment in this video. Here is the design reference for the car in the visualization. We can see rather flat shading with minimal use of colors. We can also see some outlines on the outer shape of the car, as well as some of the inner shapes like the doors and body panels. And we can see a very simple stylized shape of the car as a shadow on the floor. For the color, instead of relying on standard shading and then adapting the look with overlay or post-process materials, like I did in my last video, a team at Rivian chose to use completely unlit shaders. This goes towards two goals from earlier. It gives you full control over the visuals, you basically give your 3D surfaces flat colors, and you save on performance, since none of the calculations for lighting, shading and reflections have to be made. This is of course a very basic description of what's happening here, but you get the gist. The shadows on the ground are decals attached to the vehicle. Decals is a good move here, since they adjust to the surface underneath. They are basically projected onto the surface, and this works much better than using a simple plane geometry and slapping a shadow texture on there. Still, the shadow underneath the car is completely fake, which again gives them full control. The outlines are done in two ways. For the outer shape, they used a depth-based post-process material similar to the one I built in my last video. But for the inner shapes, they used geometry to visualize the outlines. So they basically traced on the surface of the car where they wanted outlines to appear, and then created geometry from that. Let's talk about lighting, reflections and shading, since this is something that is very important and iconic in car visualizations. When you see the light glinting on a nice car body, I guarantee you say, "Ooh, shiny" in your head. Let me know if I'm wrong in the comments. The team at Rivian did not use any lights, traditional reflection captures or ray tracing to calculate reflections and shading, which would cost performance and storage. This meant to give their 3D objects some plasticity, they had to fake reflections and shading on the surface. To once again have full control, they created textures in the UV space, which they basically painted onto the car, to have unique designed reflections for each drive mode. Since the drive modes have a default camera position and only minimal camera control for the user, this holds up rather well. As you can see from the example texture, the UV islands were optimized to minimize the use of textures. I'm also guessing that all of the body parts that the R1T and R1S maybe share have been laid out in the UV space the same, so that they can maybe reuse some parts of the textures for both cars. At least that's what I would have done. When they had drawn the general reflection shapes, they converted the sharp textures to signed distance field textures. A signed distance field texture, or SDF for short, stores the distance of a pixel to the nearest edge of a shape in the positive and negative direction, so whether it's inside or outside of the shape. This results in a blurred gradient kind of look. Using SDFs here is a good move. It allowed them to have more control over the spread of the shading and the highlights in the material. But it also allowed them to seamlessly blend between the specifically designed reflection and the calculated reflection for the drive mode transitions. If you want to learn more about signed distance fields and their use in the Unreal Engine, take a look at the UI Material Lab sample from Epic Games. Another way to save on performance and storage they used was a data table setup for each vehicle configuration that then drives a material parameter collection. Material parameter collections are material parameters that can be used in multiple materials and can be changed without having to create a new material or material instance. This means they did not have to create a material instance for each car variant or dynamically create a material instance at runtime, which would cost performance. All is handled within one single material. Smart choice. Let's take a look at how I recreated this. For the inner outlines, I made a selection of some of the sharper edges and where the body panels meet. I then separated this and converted it into curves. And with some thickness added, I have my outlines. When I put this on top of the car and slap some black color on it, then we have the inner outlines. And with the post-process material from the last video, we have all of the outlines combined. Let's take a look at how I recreated the material. First of all, I set the shading model to unlit, so I have no shading on my surface. I separated the car into two parts, the upper part where most of the reflection is going to be happening and the lower part. I then combined all of the separate materials into one slot to save on draw calls. To still be able to select the individual parts like the car body or the windows, I created a material ID mask, looks like this, and every color is for one part of the mesh. So for example, yellow is for the car body, this light blue is for the windows. With that, I could then apply colors to it. And here we can see the car body is blue, the windows are gray, and the lower part here is black. But without any shading, this looks rather flat. So let's fix that. I've tried to recreate this specifically designed reflection from the side view. In Blender, I can just paint on top of the surface of my car, like this one, and create a black and white mask. If I wanted to have really straight lines, I can also use a geometry selection like this one, and then just paint inside of that mask, like so. I could then convert this texture into an SDF, like so. Now I could use the SDF texture in my material. You can see it here on the geometry. I could then break apart this gradient into sharper shapes, a broader one for the shading, and a smaller one for the highlights. These black and white masks I could then color in, and I just used the default color, desaturated it a bit, and made it brighter for the highlights and the shading. And once I connect this here, this is the result. I built the same thing for the bottom part of the car, and once I apply these two materials, we can see the result in the scene. From this camera view, it looks okay, but once I change the camera too much, you can see it falls apart and doesn't hold up, because normally the reflections would change based on the viewing angle of the camera. Here you can see the car in a black scene with a rather reflective material. I've added some lights to show you how the reflection would normally move across the surface once I change my camera angle. Instead of the lights, I now placed two white planes here to recreate the lights. And once I hide the car and use a scene capture cube to create a 360-degree image of that scene, I can use that as a texture and project it onto my geometry. I just need to convert it to an SDF as well, which could look like this. You can see the gradient here. In my material, I can use a reflection vector to project this texture onto my surface as if it was the reflection. And in the main material, I can just pipe it through the same nodes to have the same effect as with the designed reflection. I've also built in a way in my material to seamlessly blend between the designed reflection and the captured reflection. So once I change this value, you can see it seamlessly blend between the designed reflection and the captured reflection. And once I move my camera now, you can see the reflection change across the body. Now I can add the shadow underneath the car. In this case, I'm just using a plane because I don't have an environment here. So put it underneath, scale it up a bit, and then apply the material with the mask. Something like this. And this is what it looks like now. Here we can now see a comparison between the old version and the new one. Here's the old version. Of course, it's not the same car, so it looks different either way, but you can see the difference. And here is the new version. Let's change up the reflection and orbit around. It comes much closer to the original. Of course, it doesn't look exactly the same, but that's to be expected. Let's talk about why it makes sense to go that route from a development process and infrastructure perspective. Of course, stability is very important when it comes to electronics that make your car go vroom, but also could make your car go boom. This just means if something fails, like your cameras, your speedometer or assisted driving features, it could have major consequences. That's why low latency and isolation is key for the software architecture of the infotainment system. Let's take a look at the infotainment module. It's based on the Qualcomm platform, so I'm guessing this means it runs on an ARM processor. This renders to 3 displays inside of the car: the instrument cluster, the center console, and the rear center display. The module handles phone, navigation, media, radio, and various other vehicle settings. On the center console is where the Unreal Engine visualization is literally shown on the big screen. This is where the drive modes are displayed, for example. But there's also a 2D UI with buttons where you can change the drive modes, control the temperature, etc. You could do all the buttons and the 2D UI in Unreal Engine as well, using UMG for example. This would make it easier for the development since everything is in one app and the communication between the 2D UI and the 3D visualization would be very simple to implement. But it also means that if the Unreal Engine application crashes, all of the controls would be gone. So it makes sense to approach this modularly and have separate applications for separate functions. Still, you need to be able to communicate from the 2D UI to the 3D visualization and tell it what it should render, for example. For that, Rivian makes use of the Unreal Instance Service. Unreal is not run as a package application, but rather as a system service. This service can get requests to render an image, and the final image is then displayed on some part of the screen. This makes it completely modular, and when the Unreal application crashes, the main software can just switch to a fallback and restart the service in the background, while all of the other features stay unaffected. Camera view, media, or navigation are separate apps or services so that they are independent. The infotainment module can send data to the Unreal instance, and Unreal can send back event callbacks, for example when a level is loaded. For the development of the various visualizations needed in the instrument cluster, the team has built a signal simulation app that can simulate signals from the vehicle and send them to the Unreal editor. These are the same signals that the Unreal instance would receive from the real car, and this makes it much easier to prototype and develop everything. They also had the option to record real data from the car and then play that back in the editor. Which is great, you wouldn't always have to package the application, go to a car, install it on the car, test it out, and then go back to fix things. Instead, you can just test it out in the editor and iterate much quicker with the software solution. Very cool stuff. So what can we learn from all this, and how can we approach our own development projects with these learnings? Iterative design is key. When designing something, whether it's a visual design or an interactive functionality, always start with a core idea and then refine over multiple steps. Don't expect to have an idea and find the final design right from the start. Use what you have and what you know. You don't always have to reinvent the wheel when designing something new. The goal should always be to have control, instead of trying out a new feature or functionality just for the heck of it. I'm not saying you shouldn't try something new or expand your horizons, but often the answer lies in the tools and skills you have already mastered. Focus on modularity. Build systems that can be reused and scaled. This does not only apply when creating car HMI applications, but also when you stay inside of the Unreal editor. Making use of the modular approach makes it so much easier to work inside of Unreal, since that's what you're encouraged to do instead of working against the system. Reusable material functions for materials, Niagara modules or emitters for Niagara systems, or glass inheritance and blueprints. There are so many aspects where this can apply. Optimize from day one. When you only have one target platform, this is far easier than doing multi-platform development. When you treat performance as a design goal instead of an afterthought and build your content and logic accordingly, the development process is so much more efficient. Don't start optimizing at the end and then find out you have to throw out half of your content, otherwise the application might not run smoothly. As promised, I didn't cover every topic from the talk, so please go ahead and check it out for yourself if you want to dive deeper into the subject. The way they use vertex animation to blend out the environment is a rather cool idea as well, for example. Congrats to the team at Rivian for creating something unique, bold, playful, and ambitious. What do you think about their approach? Would you have done anything differently? Did anything from the tech talk resonate with you? Let me know in the comments. I found it interesting to get a glimpse behind the scenes and see once again that even high-level brands might not need much more than the stock Unreal Editor tools to create unique and awesome-looking experiences. I hope you found these insights as fascinating as I did. If you'd like to see more videos like this, consider subscribing. Thanks for watching and see you next time.